Hello and welcome, everyone. We're really glad to have you here today for our weekly OCI Deep Dive. For those of you who might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community for end users. I'll share some resources throughout the session today that will lead you back to those CCC forums. And if you're not already a member, we invite you to create a free account, join in discussions, post questions, and look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today I'm joined by Wes Prichard, Senior Principal Product Manager, who's going to take us through some recent and upcoming AI releases that we've been doing the last few months here. I think that is enough from me. So Wes, go ahead, take it away. It's all yours.
All right. Thank you, Kenna. Hello, everybody. Good morning, good day, wherever you are. And thank you for joining this presentation today on artificial intelligence. So let's get going. So we've been having a lot of conversations with customers about AI. It's a pretty hot topic. Nearly everyone is considering it in some way, and many organizations already have AI use cases identified. And generally what we're hearing is they're looking for new insights, looking to take advantage of new capabilities. And we're also very interested to hear what you're thinking about AI. And we've got another little poll here just to get some input. So if you wouldn't mind answering this question for me. While you're doing that, I'm going to continue for a moment. So you may ask, how is Oracle different when it comes to AI? Well, we're focused on AI for business. You might ask, isn't Oracle new to AI? Well, yes and no. We've been doing machine learning in Oracle database for many years, and many of the Oracle applications have been adding AI features for years. What we've done more recently is to bring all that expertise under one roof to provide AI services that our applications can use and also provide business-friendly AI for our customers. It's like my VP, Ella Zicklick, likes to say, we want to make AI boring because it just works in your business. So I see we've got a number of answers on the poll here. I'm going to go ahead and end it and share the results. So fairly even split here. A little more than half have identified some AI use cases that you want to implement. The other, a little less than half have not. Well, for those of you that have some use cases, I hope you see, make some connections between what you're thinking about and the capabilities that we have. For those of you that haven't, I hope the presentation today will give you some ideas about some potential use cases that you may be able to employ within your own organization. All right, so let's start out and just look at some examples of some different kind of use cases. Now, consumers these days are not shy about providing feedback over social media, especially when they don't like something. So AI can be used to help analyze that feedback so you can pull out the information that you can use. And I'm going to show you a demo of this a little later in the presentation. And every business has equipment, but in some industries, certain equipment is critical to the business. That could be a machine in a factory, a truck on the highway, or a pump in the local water supply system. You can use AI to detect anomalies in the data produced by equipment and act before there's a disruptive outage. And businesses have generated paper since the invention of the printing press, and it's still around, but much of the data being generated today is digital. Things like digital documents, text from email, social media, audio from call centers, video from cameras and drones. We generate so much digital data that can be difficult and time consuming to find the important things when you need them. So AI can generate metadata that describes the media, extracts information from it, and helps make better use of it. So those are just a few basic examples of scenarios that are enabled by AI. And it's this next generation of scenarios that's driving our approach to AI and ML. For many years, the data available to organizations was the structured data in their business applications. And this is still very important business data, but it's certainly not the only data. Organizations have many types of unique and often unstructured data from many different sources. I bet each of you could think in your own business about unique types of data that you have access to. You can see, healthcare has DNA data, and everybody cares about weather. There's just lots of different sources of interesting and unique data that provides valuable information. And organizations want to be able to use all of that data to produce new insights and new data products. They want to improve their business operations by creating better customer experiences, anticipating service demand, preventing avoidable equipment outages. The next generation of scenarios means being able to use all data, and we need the capabilities provided by AI to understand and use that data. So Oracle AI is this portfolio of cloud services for helping organizations take advantage of all data for this next generation of scenarios. So notice at the bottom of the diagram, the foundation of all of this is data. Obviously, AI and machine learning work on data and require data. And at the top layer of the diagram is application. And this loosely refers to all the way that AI is consumed, like the examples I just showed, as well as business applications. Now, between the applications and data layers, you see two groups here. There's the AI services and the machine learning services. So the difference between these two groups is that the machine learning services are used primarily by data scientists to build, train, deploy, and manage machine learning models. Data scientists can work with familiar open source frameworks and OCI data science. And they can take advantage of machine learning algorithms built into Oracle database, an important service that supports both machine learning and AI services is OCI data labeling. Because if you're going to build AI models that work on images or text or speech, you need labeled data that can be used to train the models. Now, the AI services, there's specific pre-built AI functionality that is used by developers with no need for data science skills. So that's the big difference here is, you're a data scientist if you're working with these tools. You don't have to be a data scientist to consume these services. You're calling an API and you're getting results, so that's something a developer can do. Now, each of these AI services contains pre-built machine learning models. Oracle's already done the work there, all the data science work to prepare the machine learning behind those services. So some of the services contain all of the services are pre-trained. Some are trained by the customer with their own data. All are used by simply calling the API for the service. You pass in the data to be processed, and the service returns a result. There's no infrastructure to manage, and the services are priced based on the number of API calls per month. So I'm going to tell you more about each of these services as we go through the presentation today. I'll cover OCI data science and then the AI services. But before I do that, I want to provide a bit more context. So if you take that AI service layer and that machine learning service layer and you put it into this stack of different OCI services, you'll see that these AI and ML services don't stand alone. They're supported by many other services available in Oracle Cloud Infrastructure, including analytics like Oracle Analytics Cloud and Graph Analytics and Oracle Database, and many forms of data integration and data management, all running on the cloud infrastructure. So these services can be combined in various architectures to support many different scenarios. And you saw a little bit of that in those scenarios I showed you right at the beginning, how we piece together different components to create a scenario around a particular AI problem. So let's take a look at OCI data science. Now, you may not realize that Oracle has had machine learning products in the market for 20 years. but we have, and that experience has helped us learn what organizations want when it comes to data science and machine learning. And what we hear is that they want versatile and productive tools for their data scientists. And they want those tools to support the full machine learning lifecycle, like you see here in this simplified representation. So the easier and more productive we make this lifecycle, the more valuable it is to the data scientists. And that's where we're focusing. So OCI Data Science is our cloud service focused on serving the data scientists throughout that full machine learning lifecycle with support for Python and open source. This diagram shows, particularly this picture here, the basic organization of the features of the service. So work and users are organized into projects. Projects contain notebook sessions, model deployments, jobs, and access to the model catalog. Notebook sessions are where the data scientists do their work. They provide a Jupyter Lab environment with a pre-installed open source libraries and ability to add others. They also include our own accelerated data science library that you can use if you want to. So that's the Oracle sauce on all of the open source that is also provided. And I want to emphasize that the service provides all the popular open source Python libraries. It supports users bringing in their own libraries, and it provides Conda environments for managing libraries. And one of the ways that we simplify the work of the data scientists is to make it easy to get access to infrastructure. And this can be a real pain for data scientists that are not working in the cloud, because data scientists can consume a lot of compute resources depending on where they are in that life cycle. But in OCI Data Science, when users go to create a notebook environment, that's what we call the notebook session, they simply select that they want to use a CPU or GPU compute shape, and they can pick the amount of storage needed for the notebook session. And then OCI Data Science goes off and automatically creates a ready-to-work environment. And so they don't have to worry about any of the provisioning or any of that stuff. They just get to select what kind of environment they want. And then users can start with a small shape at the beginning of their project, if that's all they need when they're just initially writing Python code. When they're ready to do some model training later, they can come back and increase and change their compute shape, go from a few cores to many cores. So that provides scalability throughout that machine learning lifecycle without any reliance on IT to come back and provision resources for them. So you get better productivity that way. And the service charges only for the cost of the compute and storage infrastructure. Users can deactivate sessions to stop any compute charges and then reactivate later. So the service is providing premium features without a premium cost. Now let's start to unravel the AI services a bit. This is that same list of services you saw in the earlier diagram of just highlighting then the 6 services here that we call the AI services. And this is the same portfolio of AI services that we announced in November. And what's changed since then is that Speech and Vision, which were beta back in November, are now generally available. And Forecasting, which was still in development in November, is now in beta. So I'll take you through each of these services, and then I'm going to show you some demos for Language, Speech, and Vision. So you may already be familiar with Oracle Digital Assistant. It's been around for a few years, but we've pulled it into the AI portfolio. And ODA offers pre-built capabilities to create conversational experiences for business applications and customer interactions through text and chat and voice interfaces. I imagine most of you have probably interacted with a digital assistant of some kind over the phone or on a web page. There's AI behind that to understand and interpret written or spoken language. And it's these same proven capabilities that are shared with other AI services like speech and language. So that gives us a little benefit of scale here, because we can take these same models and use them with multiple services. Now, OCI Language allows you to easily analyze unstructured text. It has 5 capabilities, and you can see in the slide here kind of how it works. You put in a block of text, and then it doesn't have to be this short, but it works well on a slide. And then you can do any one or all of these analyses on that piece of text. So let me just talk through these. So first is language detection. It recognizes 75 languages, from Afrikaans to Welsh. It identifies entities. These are things like names and places and dates and emails and currencies, organizations, phone numbers, 14 types of things in all. You can see an example here. It picked out the year as a date and Oracle as an org. And then it identifies the sentiment of the text, but not just one sentiment for the entire block of text. It does that, but it also determines different sentiments for different aspects. So let's say you read a restaurant review that said, the food was great, but the service sucked. Well, you'll get food with positive sentiment and service with a negative sentiment. And so food and service would be the 2 aspects that it then did the sentiment analysis on. And it also does a sentence level sentiment as well. And then it identifies key phrases in the text that represent the important ideas or topics. And then it does a classification of the general topic of the text from a list of 600 categories and subcategories. So one of the exciting new features that we currently have available in our beta release is language translation. So it's more than just detection. We're actually now going to translation. The service can automatically translate across 20 languages, including Arabic, Brazilian Portuguese, Japanese, Korean, Chinese, and many of the European languages. And then another feature that's in beta is custom training of the classification model, and also of entity recognition. So if you need to do recognition of entities unique to your business, or you want to classify text in a way that's unique to your business, you can retrain those models with your own business data. Pretty cool. Now, OCI Speech service is very straightforward. It unlocks the information in audio information by converting speech to text. Developers can use those time-tested acoustic and language models that are shared with Oracle Digital Assistant, and this provides highly accurate transcriptions for audio and video files across multiple languages. So we're currently supporting English and Spanish and Portuguese for transcription. We've got batching support, so you could submit many files in a single call. It's got super fast processing. It'll transcribe hours of audio in less than 10 minutes. It'll chunk all that audio up into segments and then transcribe them all in parallel and merges it all back together. It makes the transcribed text more readable through this process called normalization. So for example, if you had a sentence that said, this laptop costs $1,355, rather than writing out each word of that number as 1,300, it would just simply replace it with the symbols $1355. So that normalization applies to things like addresses, times, numbers, URLs, and more. And that's how you would expect to see text if someone was typing it in. It also does profanity filtering, where it can remove or mask or tag identified profanity in there. And I know my mobile operator, if they always tell me they record my calls, my tech support calls, They probably would need this feature after my last session with them. It provides a confidence score per word and per transcription, and then it does punctuation of transcriptions, which that's pretty nice. Can you imagine back in school just recording your papers in audio and then letting the service transcribe and punctuate all your text for you? Pretty nice feature. We also have SRT file support, which is what allows closed captioning of video. And so pretty robust service here, even though this is a pretty new service out. Now, OCI Vision is a computer vision service that works on images, and it provides two main capabilities. First capability is for analyzing photographic images, like detecting objects inside an image, and also classifying the major features in the scene. It also locates and extracts text that appears in the scene, like on a sign or a license plate. The second capability is for working with document images. And you can use it to understand documents. It could be, any kind of scanned document image, PDFs, forms, even photographs containing textual information. The features of document AI are text recognition, which you may know as OCR, optical character recognition. And it extracts text from images, but it includes non-trivial scenarios like handwritten text. That's always been a very tough thing for OCR engines to do. It handles tilted and shaded and rotated documents. And you can see, like on that pill bottle there, how the text wraps around, and that can be a tough thing for an OCR engine, but it handles that very well. The document classification is where it classifies documents into different types based on visual appearance and various features and extracted keywords. And this is useful if you're going to process the document based on its classification. So we do 10 different types, things like invoice, receipt, resume. And so you can add that as a piece of metadata and then use that in downstream processing. Language detection, you notice we had language detection in our language service, but we've also got here in the vision service, but in this case, it analyzes the visual features of the text to determine the language rather than just purely relying on the text itself. It does, and then we have a table extraction feature. So if you see tabular data in the document, it will extract that in tabular format so that it can then be used by an application. And then key value extraction is a pretty cool feature. In some cases, it might be called intelligent data extraction, but it currently works for receipts. And what it does, it finds the values for 13 common fields that typically appear in receipts. Things like merchant name, transaction date, total amount, tax, subtotal, line items, all of that. It pulls all those out and provides a key value pairs so that can be used for an invoice processing system. I'm sorry, a receipt processing system. We're also have got invoice processing in the works. So in addition to the pre-trained models that support all those features, customers can retrain the models with their own unique data to fit their specific needs. And even though the service has only been out a short time, we're already working with some customers on some interesting use cases. So there's a bank that is using the OCR and table extraction for income analysis of new customers. So when a new customer comes in, they bring in some information like bank statements and pay slips, and then they scan those, extract information from those that help create a profile for that customer. A sports team is creating an end-to-end digital asset management system, but they wanted to be able to identify the photographs in their system where they're different players appear. They wanted to tag the images with the players. So they're building a custom model to do that. And then there's a manufacturer that's working with custom object detection to count pipes and OCR to identify railroad cars. And then a hospital is using a custom model to count cells and blood vessels in images. And an energy company is working on using the OCR and document classification to identify pipeline integrity management documents. So some wide variety of use cases there using this kind of fundamental vision technology. So now I'm going to switch gears a little bit to talk. So those first three services, or the last three services that we looked at, were kind of more of the perceptual services. You know, they're related to human perception. But the anomaly detection and forecasting we call decision services because they provide information to help make decisions. Now, anomaly detection detects anomalies in time series data. So time series data is just data points associated with a clock time. Things like equipment sensors generate time series data, but all kinds of business metrics are time-based. The cool thing about this service is that it finds anomalies not just in a single signal, but across many signals at once. And that's important because machines often generate multiple signals at once, and the signals are related. So think of like a pump that has an output pressure, a flow rate, an RPM, electrical current draw. When the pump's going to fail, anomalies may appear across several of those signals, but at different times. Now, take a look at this diagram. So the traditional way that anomaly detection has been done, or even monitoring of a signal, is you got a single signal and you put thresholds for an upper and lower limit on the value of that signal. And sometimes those thresholds have to be, you know, fairly extreme to avoid false alarms. So by the time it actually crosses the threshold and trips the alarm or the notification, the system's already failed. And all you're doing is reacting to the failure at that point. Now with OCI anomaly detection, it can look at multiple signals at once, up to 300 signals in a single model. And as I pointed out earlier, this is one of the services where it's trained on the customer's actual data, on the actual sensor signals. You start with a training data set of data with no anomalies in it. That trains the model, and then you can apply new data to it, and then it will pick out the anomalies in there. So in this case, we've got 6 sensors, and what it's doing, it's actually predicting what the value of the signal should be at any given time, and then it looks at the difference between the actual signal and the predicted signal. And when it sees a difference, it then flags that as an anomaly. So we see these little triangles are all different anomalies being detected across these signals. And way before we get to the threshold trip that, you know, that we saw up here on sensor 4. So these earlier anomaly detections give you an early time warning or early warning time difference that could be anywhere from days to weeks or months. And that's the real value here, is that by getting these early warnings, you can now be proactive about taking action. In some cases, you may have to take a production line down. So you want to do that in a controlled manner, ideally, to minimize the disruption to production. And maybe you can switch over to other equipment, and those are all kinds of actions you can do when you have forewarning of a problem that's coming. All right. Now, I'm going to show you a video of one of our customers that is using anomaly detection along with many other OCI services, but it's SailGP. So let's switch over to the video.
SailGP is a global championship. We have 8 teams that compete around the world for $1 million. They sail in F-50 catamarans that are highly technical. The F-50 is a modified boat from the America's Cup, but we've pushed that on now and we have new systems on board, new foils. In essence, it is a different boat. The mission for the SailGP team is to create sustainable racing around the world. We have this fantastic technology that we use for the boats to sail on the water, to get faster, to learn about how we can compete against other incredible athletes. We have about 30,000 data points on each F-50, so it equates to 240,000 data points per second. We account for around 40 billion data requests at every sailing session, and everything is stored on the Oracle Cloud. We move that data as fast as possible to an Oracle data center, utilizing Stream Analytics, utilizing Fast Connect, using the infrastructure that is available in the country that we're competing in. We can serve the SailGP app, SailGP Insights powered by Oracle. We can do our 2D graphics on our broadcast. We also have Liveline, which is an augmented reality graphics package, which actually covers the race course and gives an insight to what's going on the race course.
It's a test of speed right now.
So they're all powered by data, and all this information has been churned within our Oracle infrastructure. In the future, we want to give the fan the ability to choose what they want to see and how they want to see it. We're pushing the boundaries of what we can do, and with Oracle's help, we're moving that forward.
All right, so as you heard on the video, SailGP has, whoops, hold on to the next, sorry about that. All right, so as you heard on the video, SailGP has thousands of components on these F-50 catamarans. I like that name, sounds like a fighter, but and they're super fast. And it's notoriously hard to predict equipment failures under these tough race conditions. So during each event, SailGP makes over 13,000 API calls to anomaly detection with over 30,000 data points in each call to generate almost 400 million inferences. So 400 million cases where it's potentially detecting an anomaly. And there was a recent instance where it actually did detect a problem with one of the boats, which they were then able to quickly attend to, and the team was able to get back in the race. So very interesting stuff here, and an unusual use case, but kind of exciting stuff. Now, OCI Forecasting is an upcoming service. It's currently in beta. So if you're part of our beta program, you can try out and use the service. And it's used to forecast a variety of business metrics, things like it could be product demand or revenue or resource requirements, service requests, et cetera. Users can create, all you do is feed it data, and the service then applies different pre-built models that it has, and then you can generate these models or ensembles of models to maximize the forecast accuracy, and then use these models to deliver forecasts that give you confidence intervals and explainability, so you can understand why it's telling you what it's telling you, and then use that information in making business decisions. So you can see in the graph here, the gray historical data that was fed into the model. You see fitted data with the green line. You see the forecast here in this green line, and then you see the confidence interval, both upper and lower on that. So this is like the present point here, and this is what it's forecasting that metric to do. Now, if you're an existing Oracle customer and you're interested in joining the beta program to try out some of these features that I've been referring to, you can let me know. Let your Oracle contacts know, and they can help you get signed up on the beta program, so you can take advantage of those features, try those out, and we love having the feedback from customers. So the last feature I want to tell you about, our last service, is the data labeling service. So anytime you're going to build a custom model or do retraining, like I talked about for language or vision, some of these others, your training data needs to be labeled. So data labeling is the process of identifying properties to the data. So for example, if you want a vision model that recognizes sharks, then you need images of sharks, and you need those images identified by a bounding box and labeled as a shark, like you see in the example here. So OCI data labeling is a service that provides an easy and convenient way to label your data. You can assemble your data into data sets, grant access to the humans that do this labeling. They can take advantage of the rich user interface and store the data labels and collate them and prepare the labeled data for training models. And the service supports both image labeling, text labeling, and document labeling. All right, so now let's move into some demos. So the first demo I'm going to show you is going to go back to this flow that I showed you earlier. This is the customer analytics feedback flow. So the scenario here is that I'm a hotel chain operator, and I collect hotel reviews from social media. And I want to understand what it is that customers are really saying about my hotels. Well, if you go through these one by one with humans, it can be very tedious, and if you got many people doing that, you get inconsistent results. So in this scenario, we've pulled all these hotel reviews off social media, consolidated them into CSV files, just comma separated values files, and loaded those into object storage. Now, at that point, we use data integration service to read in those files, invoke the language AI service to do all of its functions, and write the results into autonomous data warehouse. And that data warehouse then is supporting an Oracle Analytics Cloud instance, and that's where we can actually analyze those results. So what we're going to see in the demo is this OAC canvas where we'll look at the data that was generated. We'll see both the original reviews and the data that was extracted out of those. All right, so now I'm in Oracle Analytics Cloud, and I've got 3 canvases here, and let me just take you through these. So the first thing we're seeing is some of the information that was extracted. Remember when we were talking about language, one of the things it does is aspect-based sentiment analysis. And so these are different aspects that were picked out by the sentiment analysis feature. And then it gives a count of how many times or how many reviews that aspect showed up in. So it kind of gives us an idea of what were the important things that people had some sentiment associated with. And these are what you might expect: room, parking, hotel, pool, service, breakfast. We got some entity information out of here, locations, different what we call products, but things you would run into in a hotel: the pillows, the refrigerator. And up here, this is focusing on the negative sentiment, or the negative aspects in the sentiment. So we can kind of focus in on these spikes. And this one represents 28 negative sentiments associated with breakfast. So that might be something we need to look at if we're trying to find out what our customers are saying. So let's go to the next canvas. All right, we see a bar chart here with both accounts of reviews by positive and negative sentiment, and then a word cloud associated with just the negative sentiment. Now, there's multiple years of data here, so we don't need to be really looking at all of that. The older data is probably not relevant to our current situation. So let's just look at the last 4 quarters of data. We'll highlight those quarters, our word cloud updates, and we see that breakfast is now a prominent item in the word cloud. And I can drill right into those reviews, and what takes us to the third canvas. And now I can see a list of the actual reviews where that negative sentiment occurred. And if I just use my browser to highlight all the word breakfast in all those reviews, now I can easily kind of pick out what's going on here. And what we see are some things like, well, people didn't like paying extra for the hot breakfast, or they thought it should have been complimentary, especially if they were Premier Gold member. Some people had some issues with the staff or the cleanliness of the area, or the selection of the breakfast, but all of this is very useful and actionable information. So I can look at this by time, even by day of the week, and that might help me understand if I've got a staffing training issue, if I've got something I need to focus on in this particular hotel to be able to improve customer sentiment around breakfast. All right, let's go on to the next demo. I'm going to talk to you about and show you the speech service next. So I'm going to log into my Oracle Cloud instance. All right, and you'll find all of the AI services under Analytics and AI. You can see they're listed all out right here. We'll go to Speech, and to transcribe some text, you need to create a transcription job. But before I start the job, let's look at what it works with. So this is a different application called Audacity that just shows an audio waveform. And I'll come back and play this for you in a minute, but let's go ahead and get our job started. I've taken this file and I've already uploaded it to object storage. And I'm going to create a new job to do a transcription. And it's looking at a particular object storage bucket that already contains the file that I just showed you visually. So we're going to select that as our input, and then we'll submit the job. The job only takes a few seconds to run, but instead of staring at the job, we'll go back and play the audio file here, and you can hear what it's going to do.
I'm having an issue hearing my wireless headphones. I think my Bluetooth connectivity to the TV is not working. I have high quality headphones, so I know the issue is not with them.
Hi, thanks for contacting support. I'm sorry to hear about your Bluetooth issue. Can you confirm the wireless headphones are fully charged?
Yes, they're 100% charged.
Is this the first time connecting the device to your smart TV?
No, they were working fine yesterday.
Okay, thanks for this information. Let me pass this information on to a support agent and they will be in contact shortly. Thanks. Okay,
so a interaction between a human and a robot and trying to get a problem fixed with their TV. All right, let's go look at our job. and it has succeeded. And we click on the file, and we see here the actual transcription. And I'll just read a bit of it. It says, I'm having an issue hearing my wireless headphones. I think my Bluetooth connectivity, the TV is not working. I have high quality headphones. I know the issue is not with them. Then we hear the second voice come in. Hi, thanks for contacting support. So we get a very accurate transcription of those two voices. One of them switches a robotish kind of voice. We get punctuation in here. We get normalization and the fact that it says symbolically 100%. It even capitalizes TV. Very, very good transcription of that audio information. And that's speech for you. That's what it does. All right, so let's now go look at Vision service. We'll come back here and go into Vision. Now, one of the interesting things about the Vision service, it's got this capability to kind of try out the service on images right here in the OCI console. Even though for a production scenario, you would be probably calling it from some other application or piece of code. In this case, you could just try it out. So if you go to image classification, it's got some default images already in here, and it will do a classification on those. So we see in this default image right here, the labels that it produces. And remember, that's what classification does. It's not picking out particular objects, but it's giving you labels for the entire scene. So we get an overhead power line, transmission tower, plant, sky, line. All good information. Now I've got some other images ready to go here that I will show you. This is another scene. This is a photograph I took outside of where I live in Colorado. That's Pikes Peak there. A nice rural scene. We see sky, grass, plant, mountain, horizon. Okay, a nice horizon here. Lots of sky. Let's look at something a little more urban. Anybody recognize this? Pretty iconic picture of London. We see the Tower Bridge there. We see Thames River. We see some of the other iconic buildings. So we get skyscraper, water, building, bridge, boat. All good descriptions of this particular scene. All right, let's go into object detection. Now it's going to load a default image here. So we'll let it do this one. This is an interesting scene, lots of stuff going on here. Appears to be a driveway out in front of a building in a city. We see a car with a Oracle logo on it. And in object detection, then we've got bounding boxes around each of the objects that it has detected. So we see car, bus. Back here on the sidewalk, we see person. Over here, we've got a car, and even that fraction of a taxi you see there is identified. Now, but there's more information in this scene. Those are the labels. Let's look at some text that it also pulled out of the scene. So it read the Oracle logo on there. It read the license plate. It even got the sign on the bus, and even I think there's even a little tiny sign way back here that it reads. It reads some information off the taxi cab. So a lot of text that it actually is able to pull out of that scene as well. Now I've got some other examples. Let's take a look at. All right, on this one, We've got kind of an odd little scene here. We've got these large round objects, and then we've also got a person, and that's really the only thing it detects. It might be a strange place to expect to see a person. Now these objects are microwave transmission antennas. And so somebody may be up there inspecting those, but notice it's not detecting those because our model is not designed to detect those. But if you were a telecommunications operator and you wanted to be able to detect those as objects, then you could retrain the model to do that. Here's a hospitality scene. Now it's got two people with their backs to us, but it pulls a lot of information off of those two people. They're fairly, prominent in the scene. We see man, hat, we see sun hat, human hand, and they're a woman, leg, feet, or footwear for the feet. We see the house detected over here. So lots of information there. No text in that scene. Here's another one that's kind of interesting. A sports scene here. We see two cyclists out on the road. Even though they're hunched over facing away from us, they're still detected as persons. And what I think is interesting, we can tell that the person is on a bicycle. It tags the bicycle, but because the boxes are nested, you could infer that this person is riding the bicycle and that the bicycle has a wheel, which is usually a good thing if you're on a bicycle. Same thing over here with even further away, a person on a bicycle. So that's object detection. Now let's do document AI. I'll show you one example here, and then we'll look at the questions. So this one is doing document AI on a receipt. And you can see everything that's gray here has been extracted. And that's what's shown here, either represented by line or by word. Since it's a receipt, it also pulled out the key value pairs and the line item detail. And there's a table here. So we see both the Americano and this very expensive water. So it basically extracted every piece of information that you could extract from this receipt. All right, well, let's go back to our presentation. And there's some resources here that I put together. Ken is going to share that with you, so you actually have links that you can click on. But let's take a look at the questions in the time that we have left. See, there's no open questions. Looks like a few have been answered. So Sherry, is there anything else we should cover?
One question that I commonly get about OCI Vision is whether the labels are automatically generated.
So in classification, the image classification feature that you saw, those labels, yes, is what it's automatically generating. But if the question is pertaining to labels to train the model, those are applied using like the data labeling tool, and it's humans that are then looking at the image, applying a label to the scene, and then that's fed into the training process to retrain the model.
Okay, and I think that's related to a question that I find very interesting, which is whether you can talk about some of the choices that have been made to make it easier to use multiple of these services together.
So is the question, can these services be used together?
I think it's more around maybe some of the architecture choices, or when Oracle was designing this suite of services, what were some of the choices made so that it's easier for the end user to be able to make some of the choices that, in this case, I'm thinking about OCI data labeling too with some of the other services.
Well, so we specifically design these services to be accessed through an API, which in one way gives you the maximum amount of flexibility in using these AI services in any kind of application. So any piece of code that can call a REST API or even a language-specific SDK can take advantage of these services. That piece of code that's going to call the service, will take the source data, pass it into the service provides a result back, and then you do something business specific with the result. Now, we also provide ways like in one of the examples, our data integration service, we're adding capabilities into the data integration service to be able to easily invoke the AI services for specific types of scenarios. So like you want to do bulk processing of text, for example, you could use the data integration service as a way to grab that text that's all been staged in object storage or database or any common data source, and feed it into the language service, and then spit the results out to another data source. So there's a number of architectural options available for using these services. And I think there's no one right answer to what the right architecture is. It depends on how you're going to use it, what your business scenario is, that and what it's integrating within the business. All right, so we have put up our conclusion poll. I think we're wrapping up for today. We're maybe a minute or two over, but I hope you will fill out the poll. We'll have your feedback and any additional information we can share. Please get in touch with us.
Excellent. Thank you, Wes, for this presentation and all these amazing resources. I will share all of these out to folks who attended, so you'll be able to get all these links and blogs and labs and tutorials and all these various things as well. As mentioned, yes, we love your feedback on that poll that popped up. We always like to hear a little feedback on how these sessions went. And we hope to have you back for another session in the future. So join us whenever you see an event that you're interested in. And Wes and Sherry, thank you so much for spending your time with us today for this particular event. And I hope everyone has a wonderful rest of their day.